All right, what we've got is an example of something being launched at an angle. Works the same way as any other projectile problem. What we're going to do is we're going to fill in our table with the things we know. Um, we don't know a heck of a lot. Uh, we know that the acceleration in the vertical direction is negative 9.8 meters per second squared. It's due to the force of gravity. We know the acceleration in the horizontal direction is 0. We don't know anything about the change in position in either direction. V0, we know a little bit about the original velocity of the football. We know that it's 27 meters per second launched at 30 degrees. We'll actually have to calculate our vertical and horizontal from that using Chief SOHCAHTOA. V final we don't know uh, for either direction. And T we know. Um, let's see here. Wait a minute. We actually do know something else. Uh, in the vertical direction, if we're looking for, in fact, let's go ahead and do that first. If we're looking for range first, which would be the best way to go, um, what we're looking at is that this thing launches and lands at the same height. So what that means is that change in position is going to be 0 since it launches and lands at the same height. We're going to have to make that assumption. So let's go ahead and do that. State that. Assume football launches and lands at same height. So that change in position in the vertical direction equals 0. All right, so let's go ahead and figure out our original velocities from Chief SOHCAHTOA. What we've got is we've got this football being launched at 27 meters per second and at an angle of 30 degrees. So we're going to break this into the horizontal component. That's V0 in the X direction and V0 in the Y direction. We're going to use the Chief to calculate that. So let's go ahead and get that going. So in the Y direction, vertical direction, we're going to be looking at 27 times sine 30 degrees. In the horizontal direction or the X direction, we're looking at 27 times cosine 30 degrees. Let's go ahead and grab a calculator and figure that out. So we got 27 times sine 30 degrees. It's going to be 13.5 meters per second. And then in the horizontal direction, we've got 27 times cosine 30 degrees. And you know what? I want to check my mode. Yes, I am in degrees. So 23.4. So for the horizontal direction, 23.4 meters per second. And in the vertical direction, 13.5 meters per second. All right, now we're ready to go ahead and start looking for the range. That's going to be, the range is the horizontal change in position. So range, and let's do this. Range is the same as change in position horizontally. So So this is what we're looking for as far as range goes, right there. Um, in order to do this, we're probably going to need time. So that's where this hang time comes into play. We can kill two birds with one stone here. Let's look for the hang time and the range. Hang time is going to be equal to the time for the whole trip. That's going to be up and down. And then maximum height is self-explanatory. We'll take care of that later. All right, so hang time. What we need is time in the air. Looks like we've got the most information in the vertical direction, so let's go ahead and use that to try to find hang time. So hang time in the vertical direction, change in position is equal to v0t plus 1/2 at squared. We know the change in position is 0. v0 is 13.5 times time plus 1/2 times negative 9.8 times time squared. So we need to solve this. Subtract 13.5t from both sides, so we get negative 13.5t is going to be equal to, going to go ahead and multiply this out, negative 4.9 t squared. I'm going to divide both sides by t. If I divide both sides by t, t cancels on this side, t squared goes away on this side. I'm going to go ahead and divide both sides by negative 4.9, and I get t is equal to negative 13.5 divided by negative 4.9, which is going to be equal to a positive 13.5 divided by 4.9, positive 2.76 seconds. 2.76 seconds. So my time, 2.76 seconds, and then 2.76 seconds. At this point, I can now find my horizontal range. So that range is going to be in the horizontal direction. We've got, again, change in position is equal to v0t plus 1/2 at squared. So in the horizontal direction, I've got change in position is going to be equal to v0, which is 23.4 meters per second, 23.4, times that time, which was 2.76 seconds, plus 1/2 times negative 9.8. Oh, wait a minute. That's not negative 9.8. In the horizontal direction, acceleration is 0 times 0 times t squared. Oops, let's go back and put the number in. Not that it's going to matter. 2.76 seconds squared. Not that it's going to matter because 0 times 1/2 times 2.76 is going to completely drop out because 0 times anything is 0, so I'm not worried about that. So my change in position is going to be 23.4 times 2.76, which is going to wind up being, let's see here, times 23.4, 64.5 meters. 64.5 meters. So we've got hang time. Let's go ahead and box in some answers here, although I'm going to fill it into the table too. Here's my hang time. Here's my range. And the only thing we have to do next is figure out the maximum height. We'll talk about that in a minute. So let's get rid of this question mark. We now know this. It's 64.5 meters. Maximum height. Let's make another column for this. Maximum height is a change in position, so this is what we're looking for. V0 we know is going to be, well, here's what we're going to do. Let's go ahead and draw this. What I've got is I've got this football follows this trajectory. Maybe I've got this drawn already. I do. It follows this trajectory here, follows this trajectory here. At the top, this is my max height right here. That max height at the top, V0 is equal to 0. What we're going to do is we're going to pretend we're at the top and we're just dropping this thing. We're only going to look at half of this. We're going to look at this half of the trip right here. So for the max height, look at second half of trajectory. So essentially what we're doing is we're pretending this thing's dropped. So since it's V0 at the max, we're going to say that V0 is 0. We don't care about the V final. The time, keep in mind it goes up for half the time, down for half the time. So the time is going to be 1/2 of our original time, which is going to be 2.76 divided by 2, which is, let's go ahead and divide that, 2.76 divided by 2. It's going to be 1.38 seconds. So time is 1.38 seconds. And then since we're looking at the last half, it's dropping. So that acceleration is still going to be due to gravity. It's going to be negative 9.8 meters per second squared. Now I think I am going to have to go to the next page because I need some room to make this calculation. For max height, again, we're looking at the second half. So we're looking at how far it fell, essentially, change in position. This is in the vertical direction. Change of position is going to be V0t plus 1/2 at squared. Well, we said that V0 was 0 times 1.38 seconds. I'll show you where I got that from. Here's my V0. Here's my time. And as long as I'm here, here's my acceleration. Again, I'm figuring out max height. So let's go ahead and go down here. Plus 1/2 times negative 9.8 meters per second squared times the time squared, which is 1.38 seconds. We're going to square that. So again, this completely drops out. Gone. 0 times anything is 0. And we get um, 1/2 times 9.8. You know what? I'm just going to do the math and get the answer. So what we've got is 0.5 times uh, negative 9.8 times 1.38. Put parentheses around this. I'm not sure if it needs it, but I'm going to overkill here. Squared, which is going to be 9.33 meters negative, but that's going to be a positive when we're talking about how high it goes. I just want to check the math one more time. 1.38 squared, enter, times 9.8, enter, times 1/2, enter. Yeah, 9.33. Okay, so it's 9.33. Again, this came up to be negative 9.33 meters, but we want to know that's how far it fell. Well, how far it would go up is this half of the trip. So how far it would go up is 9.33 meters. So let's go ahead and get rid of our question mark. We'll go 9.33 meters. Let's go ahead and put a box around that. Those are our three answers. And again, this would be a positive for how high it would go.